Okay, Year 11, here's the solutions to the first homework. Okay, part A is asking us to find a factor of 96. Well, a factor is a number that divides exactly into another number without any remainder, and after looking through the list you should be able to see that 32 goes into 96 3 times. A cube number is the result of multiplying a number by itself 3 times. So 1 times 1 times 1 would be 1, but that's not in the list. 2 times 2 times 2 is 8, but that's not in the list. But 3 times 3 times 3 gives me 27, which is in the list there. A multiple of 8.5, if you're looking for multiples, it's basically you're looking at your 8.5 times tables. Obviously you probably don't know that, but if you just keep adding 8.5 on, eventually you'll get to a number which is in the list, and that would be 34. A prime number has 2 factors only, no more, no less. You can think of it as being 1 in itself. The only exception to that would be the number 1. And 2 of the prime numbers in the list would be 31 or 29. Okay, next question. You're asked to circle true or false for the following statements. The best thing to do here is to work them out, and then you can decide whether the statement is true or false. So the first one, it says 20% of 70 is the same as 70% of 20. So I would work out 20% of 70 first. So we can find 10%. 10% of 70 is going to be 7. To find 10% you just divide by 10, and then to get 20% you just need to double it. Okay, then I'm going to work out 70% of 20. So 70%, sorry, again you're going to find 10%. 10% of 20 is going to be 2. 70% I'm going to have to times by 7, which gives me 14. And you can see that they're both the same, so that statement there is true. Okay, a half of 8, an eighth, is the same as an eighth of a half. Well, the word of means that you're actually multiplying them together. And to multiply fractions, you times the tops and you times the bottom. So 1 times 1 gives me 1. 2 times 8 gives me 16. And then this one here, 1 times 1 is 1. 8 times 2 is 16. And you can see that 1/16 is the same as 1/16. So again, that's true. Okay, a number is halved, the answer is halved, and then the answer is halved again. Again, make up a number. You can pick any number you want. I'm going to pick, say, 36. I'm going to write it on the side here where I've got some room. So if I half that, that's going to give me 18. The answer is halved again, which gives me 9. And then the answer is halved again, which gives me 4.5. What it says here, that a number is halved, the answer is halved, and then the answer is halved again. This gives the same answer as dividing the original number by 6. But if I divided the original number by 6, 36 divided by 6 gives me an answer of 6. So 4.5 and 6 are not the same, so that's false. Okay, next one, dividing a number by 15 is the same as dividing by 10 and then dividing the answer by 5. So again, pick a number, pick a nice number that can be divided by 15, something like 30. So I'm going to write this on the side here. 30 divided by 15 gives me an answer of 2. What it's saying, that's the same as first dividing by 10 and then dividing by the answer by 5. So 30 divided by 10 would give me an answer of 3. And then 3 divided by 5, you might not know what that is, it's 0.6, but you can see there's going to be 0 point something, which is not the same as 2. So that one again is false. Okay, multiplying a number by 2.5 is the same as first multiplying by 10 and then dividing the answer by 4. So again, pick a number. I would pick a nice number, something like 10. So 2.5 times 10 gives me 25. Okay, well then it says that's the same as first multiplying by 10 and then dividing the answer by 4. So 10 times 10 gives me 100. 100 divided by 4 gives me 25, and those two answers again are the same, so that statement there is true. Okay, next question says that Charlotte write down 3 different factors of 20. The sum of the factors is greater than 10 but less than 15. What 3 factors could Charlotte have written down, and you must show how you worked out your answer. So the first thing I would do here is work out all my factors, and it's easy if you do them in pairs. So think of 2 numbers which multiply to make 20. So we've got 1 and 20. 2 and 10, 4 and 5. So they're all my factors of 20, and she picks 3 of them. Some means add, so 3 of those factors are going to add to be a number greater than 10 but less than 15. Well, obviously the number 20 is greater than 15, so there's no point in even considering that one. So we've got the other 5 factors to deal with, and there's 2 combinations. You could have 1 plus 2 plus 10, which is going to give me 13. If I did 1 plus 4 plus 10, that would actually come to 15, but it says here it's going to be less than 15. So the other pair, the other 3 that I could have would be 2 plus 4 plus 5, which is 11. So there are your 2 choices you could have there. B, simple number machine, is a little bit more tricky because you've got a negative input. So if I put minus 2 in as my input, and then I add 5, minus 2 add 5 gives me 3, and then I put in 3 and I'm multiplying it by 7, so I should end up with an answer of 21. Okay, next question, 0.4 times 0.7. Forget the decimal points are there and just do 4 times 7, which is 28. And then you can see you've got one number after the point there, one number after the point there. So altogether in the question you've got 2 numbers after the point. So I need 2 numbers after the point of my answer. So for that to happen, the point would need to be there. And really we shouldn't just leave it as 0.28. We need to put a 0 in to show that there's nothing before the decimal point. Next question here, probably best way to work out if you can't do it in your head is to set it out in columns. Put your decimal points in first so that you make sure that all your numbers line up in the correct columns. So you've got 13.8 and then you've got 7.45. If you've got any gaps you can fill them in with zeros if it helps. And then I'm always doing the top take away the bottom. I can't do 0 take away 5, so I need to borrow from my next door neighbour. So that becomes 7, and the one I borrowed makes that 10. Now I can do 10 take away 5, which is 5. Then I can do 7 take away 4, which is 3. Put my point in line. 3 take away 7 I can't do again, so I need to borrow from my next door neighbour, so that's going to become 0, and the one I borrowed makes that 13. Then 13 take away 7 is 6, and 0 take away 0 would be 0. So you can write that down if you want, but you don't need to. Okay, next question C. You've got 3 to the power of 3 take away 2 to the power of 4. Well, the power tells me how many of these I need to multiply together, so that really means 3 times 3 times 3. Take away 2 to the power of 4 means I've got 4 2's multiplied together. 1, 2, 3, 4. 3 times 3 times 3 is 27. 2 times 2 is 4. Times by 2 is 8. Times by 2 is 16. 27 take away 16 is 11. Okay, next one. 5 to the power of 2, so that means 5 times 5 times 2 to the power of 3 means 2 times 2 times 2. 5 times 5 gives me 25, and then I'm multiplying that by 2 times 2 times 2, which is 8. 25 times 8 is 200. If you couldn't do that in your head, you can set it out using the column method like that. 8 5s are 40, so we carry 4, write my 0 in. 8 times 2 is 16, plus the 4 gives me 200. Okay, next question. Use the following clues to find the missing number. So the numbers between 1 and 20, it's not an even number. So if it's not an even number, that means we got all the odd numbers between 1 and 20. So it says between 1 and 20, so that's not going to include the number 1. So the first number is going to be 3, then 5, then 7, then 9, 11, 13, 15, 17 and 19. Then it says it's a multiple of 3, so that means it's in the 3 times table. So our 3 times table, we could have 3, 9 or 15, so we can forget about these numbers. So we're just concentrating on 3, 9 and 15. And then the last clue says it's a square number, so square number is a result of multiplying a number by itself. And you should be able to see that 3 times 3 gives me an answer of 9. So the missing number is 9. Okay, are the following statements true or false? Circle the correct answer. You must give a full explanation for your decision in each case. When a number ends in 8, when a number that ends in 8 is divided by 2, the answer is always a multiple of 4. So pick a few numbers that end in 8 and divide by 2 and see what happens. So if I pick maybe 18 and maybe 28, if I divide 18 by 2, that gives me an answer of 9. Well, I've already just showed that if a number ends in 8 and you divide it by 2, then it's not always a multiple of 4, because the multiples of 4 would be 4 then 8. Okay, and also 28 divided by 2 is 14, and that's not a multiple of 4 either, so that's going to be false. The last question, when two consecutive numbers are multiplied together, the answer is always an even number. So consecutive means one after the other, so 3 and 4 is a consecutive numbers, or 5 and 6, or 10 and 11. So if I pick two consecutive numbers, say 3 and 4, if I multiply them together, that gives me an answer of 12. If you want to do one more just to be safe, you could do 6 times 7, which gives me an answer of 42, and you can see both of those are even numbers, so that's going to be true. Okay, a lot of information given here in the question, but basically what it means is these two blocks add up to make the block above. So 1 plus something is going to make 6, so it's got to be 5. 5 plus 3 makes the 8 above. 3 plus something there makes that number there, but we can't do that yet because we haven't got enough information. But you could see that 8 plus something makes 28, so this number here has got to be 10. Now we can do this one. 3 plus something makes 10, so that's got to be 7. And then 6 plus 8 makes 14, and you can check the 14 plus 28 does make 42. Okay, next question. Are the following statements true or false? Circle the answer. You must give a full explanation for your decision in each case. So a squared plus b squared is always an even when a and b are whole numbers. So again, let's try some different numbers for a and b. You can choose them yourself. So you could pick 2 squared plus 3 squared. If I work that out, 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. Well, I've just proven that that is not always even, so that statement there is going to be false. You need to make sure that you give an example to get your marks. You can't just guess. Okay, next one, a squared b squared. Well, that in algebra that actually means a squared times b squared. So again, let's try some numbers. So we'll use the same ones. 2 squared times 3 squared would mean 4 times 9. 4 times 9 is 36. And what does it say? Sorry, I haven't read the question yet. Ignore that, because it says a squared b squared is always an odd number when a and b are odd numbers, so we need to use odd numbers. Okay, so if I tried 1 squared times 3 squared, that's going to give me 1 times 9, which is 9. Okay, it works for those. Let's just try another pair just to be safe. So if I try maybe 3 squared times 5 squared, 3 squared is 9, 5 squared is 25, 9 times 25 is 225, which is odd. So that is going to be true because you've got 2 odd answers there. Okay, we can't complete the Venn diagram because there's no numbers given. There must be a mistake with the photocopying, so we'd have to ignore that one. Okay, so express 144 as a product of prime numbers in index form. So that's our prime factor tree. So we start at the top, 2 branches come out from it. Think of 2 numbers which are going to multiply to make 144. So it's going to be 2 and 72. And then we circle our prime numbers. 2 is a prime number, 72 isn't, so we keep going. So we've got 2 then times 36. Circle our 2. Then we've got 2 and 18. Circle our 2. Then we've got 2 and 9. Then 3 times 3. And once we've got cherries at the end of all our branches, we can stop. And my answer then is my cherries multiplied together. So we've got 2 times 2 times 2 times 2 times 3 times 3. And we need to make sure if we put it in index form, we need to use power, so we go 1, 2, 3, 4, 2's multiplied together, so we'd write that as 2 to the power of 4 times 2 3's multiplied together would be 3 to the power of 2, and that's my answer there in index form. Okay, for B, there's two ways of doing this. You can either write down all the factors of 144 and 60 and then find out which is the highest in both lists, or you can use this information that we've been worked out from the first one and you're given here to work out what the highest common factor is. So the number 144 can be written as 2 times 2 times 2 times 2 times 3 times 3, and as 2 times 2 times 3 times 5. So the highest common factor is basically the numbers which are in both multiplied together. So we've got a 2 there and a 2 there. We've got another 2 there and another 2 there. And we've got a 3 there and a 3 there. And we can't do any more because we've got a 5 here but it's not in that one. We've got a 3 there but it's not in that one, and we haven't got any more 2's left in here. So my highest common factor will just be those multiplied together, which is going to be 12. The lowest common multiple, the only way to do that is you keep writing out your 144 times table or your 60 and your 60 times table until you get to a number which is in both lists. But this can be quite difficult as the numbers will get quite big. So again, we can use what the information we're given from A and B to work this out. So what we do for this one, if I just write down 144 equals 2 times 2 times 2 times 2 times 3 times 3, and 60 is 2 times 2 times 3 times 5. The lowest common multiple is basically the numbers which are in both lists and whatever's left over. So we've got a 2 there and a 2 there, a 2 there and a 2 there, we've got a 3 there and a 3 there. So it's like your HCF, but then we also multiply by the numbers which are left over. So we've got a 2 there, 2 there, 3 there and a 5. So it's 2 times 2 times 3 times 5, and we've got to work all that out. 2 times 2 is 4, 4 times 3 is 12, 12 times 2 is 24, 24 times 2 is 48, 3 times 48 is 144, and then 5 times 144 is 720. If you're struggling to do those in your head, then you can do some side working to work that out on a non-calculator paper. Okay, last page, working out in standard form. So for this question here, probably the easiest way to do this is to convert the bottom one into standard form. So that's going to be 5 times 10 to the power of 3, because we've got 3 digits after the first number there. 10 to the power of 3 is 1000, 5 times 1000 would give me 5000. Okay, as we're dividing them, we divide the numbers at the front, so 7.5 divided by 5. If you can't do that in your head, you'd have to use the bus stop method. So we've got 7.5 divided by 5. 5 goes into 7 once, remainder 2. 5 goes into 25 5 times, so you end up with 1.5. And then that would be times 10 to the power of, when we're dividing, we subtract the power. So 6 take away 3 is going to give me 3. Okay, when we're adding numbers in standard form, we need to convert them into ordinary numbers first, add them or subtract them, and then change them back into standard form. So 2.3 times 10 to the power of 3 is going to be 2, 3. The power of 3 tells me that I've got 3 digits after the 2, so there's 1, and then I need to add 2 zeros, and then I'm adding 6.4, which I write down as 64, and the power of 4 tells me I've got 4 digits after the decimal, 4 digits after the first digit, so the 4 would be one of them, and I need 3 zeros. Again, if you can't add that in your head, write them out in columns and add them. Make sure your columns line up. So you've got 0 plus 0, 0 plus 0, 0 plus 3, 4 plus 2 is 6, 6 plus nothing is 6. So that comes to 6, 6, 3, 0, 0. But make sure you change it back into standard form. So it's going to be 6.63, because your number at the beginning has got to be from 1 up to, but not including 10, times by 10 to the power of. So you've got 1, 2, 3, 4 digits. So it's to the power of 4. Okay, last one, we are multiplying numbers in standard form. Again, probably the easiest way to do this one would be to change the 3000 into standard form. So we've got 4.1 times 10 to the power of minus 5 times, that's going to be 3 times 10 to the power of 3, because we've got 1, 2, 3 digits after the 3, so the power is 3. And then when we multiply numbers in standard form, we times the numbers in front, so 4.1 times 3 would be 12.3. Again, if you can't do that in standard form, do it on the side. And then we add the powers of 10. So it would be times 10 to the power of minus 5, add 3 would give me minus 2. Okay. Problem with this is it's not in standard form at the moment because this number needs to be from 1 up to but not including 10. So we need to change that. And what we do is we write it as 1.23 and add 1 to the power, which gives me 10 to the minus 1. Okay, next one, I think it's divide. So we've got to do 1.5 divided by 3. 1.5 divided by 3 is actually 0.5, not 2, as some of you may be thinking. And then it's going to be times 10 to the power of, we've got to subtract the power, so 3 minus 6, which is going to give me minus 3. Again, that number there is not in standard form. So because it's less than 1, we're going to change it to 5, and then we will need to subtract 1 from the power. So minus 3, take away 1 will give me minus 4. And there's your answers for the homework.